factor expressions. And so I kind of split my paper up between problems I'm going to factor on the left and the 3 techniques that you have to know about factoring. So I'm going to start with factoring out the greatest common factor. This is like the first technique that you should be familiar with factoring. And it works whenever you have an expression where the terms have a greatest common factor that's not 1. So for in this case, in this example, the greatest common factor is, well, 2 from 6 and 8 and x. So the greatest common factor is 2x. I can factor this expression, so I'm going to copy it again, 8x squared plus 6x. I can factor it by kind of undistributing the 2x and then writing an expression that's equal to the original expression. So if I took 2x out of 8x squared, I'd end up with 4x. And if I take 2x out of 6x, 3. And I know that I got the right answer because if I distribute it back, 2x times 4x is 8x squared. 2x times 3 is where that plus 6 comes from. So I know I got the right answer. So this is the factored form. I factored out the greatest common factor. Look at another one with the greatest common factor that I could factor out. Let's do 2x squared plus 4x plus 80. Well, in this case, again, there's a greatest common factor. What's the biggest thing that goes into each of these? Well, it would be 2x if I was looking at just the first 2 terms. But in all 3 terms, the greatest common factor is just 2. So I can factor out a 2 like this. 2 times x squared plus 2x plus 40. This is the factored form. Okay, so if you're familiar with looking for the greatest common factor, oh, actually I should give you one more example of factoring out the greatest common factor. Sometimes when we do trickier factoring problems, we'll end up with factors that look like this. Really, this should just make you think of factoring out the greatest common factor. In this expression, there are 2 terms. There's one here, there's one here. Each of these terms has a greatest common factor of x plus 5, right? It's over here, and it's over here. So if I was going to factor out the greatest common factor, just like I did in these examples, I could start with the greatest common factor of the 2 terms, which in this case is x plus 5, and then include the rest of the terms, 3x plus 4. Being good at noticing when you have factored forms that look like this, noticing that there is a greatest common factor and allowing you to factor it out will help you get over the hump in some of the hardest factoring problems. Okay, so that's factoring with the greatest common factor. Not all expressions, though, you can't factor every factorable expression just by doing that. Sometimes you have to know the sum and product patterns. And I kind of crossed out add and multiply because really the nice term for that is sum and product. Here's what the sum and product patterns are. First of all, we're going to start with an expression in factored form. And I'm going to expand it or simplify it. So to simplify this expression, well, I get x times x squared, x times 3, 2 times x, 2 times 3. And I should combine these like terms to have x squared plus 5x plus 6. Okay, so here's the pattern that you'd notice if you've done a bunch of these examples. 5 is the sum of 2 and 3. 6 is the product. 2 times 3. Notice how this expression is formed of a sum and a product. And I really should just say 5 is the sum, 6 is the product, even though there's an x there. So to factor expressions like that, we can use the sum product rule in a case like this. To factor this expression, I'm going to look for two numbers whose sum is 5 and whose product is 4. Well, if I think of the factors of 4, the numbers that I could multiply to get 4, the factors of 4 are 1 times 4 and 2 times 2. These guys add up to 5, which I want, and these guys only add up to 4. So I can put them back in my pattern. Remember, I had two numbers that add to 5 and multiply to 4, plus 1 plus 4. That's the factored form of x squared plus 5x plus 4. Let's do another example, maybe with some trickier numbers. X squared plus 17x plus 72. Okay, well, I know I need to find two numbers whose sum is 17 and whose product is 72. To narrow down my search, I'm going to look for the factors of 72 that add up to 17. So I always start with like 1 and the number, so 1 and 72. Then 2, and 2 times what? 72, that's 36. 3, well, I know 7 plus 2 is 9, which is a multiple of 3. So that means 3 goes into 72. 24 times, I believe. 4 goes into 72 18 times. 5 isn't a factor of 72. 6 goes into 72 12 times. And I got one more factor, which is 8 and 9. Well, that doesn't add up to 17, nor does that, or that, or that. This one's close, adds up to 18, and this adds up to 17. So I found the numbers that make a product of 72, right? 8 times 9, and 8 plus 9 equals 17. So I could factor this as x plus 8 times x plus 9. So that's how to use the sum and product rule to factor a trinomial. Okay, there's two extensions to this, which I'm going to show you in the next video. But for right now, if you know these two basic steps of factoring, you're on the way to being really good at factoring.